All right, good afternoon, guys. I'm here with a video response to black pen, red pen. My name is Zach, and we're going to go ahead and solve for the nth term of the Champernowne Constant, and we'll solve for the 1,000th digit later, like he had asked for. And we're going to jump right into it because we don't have a lot of time in this video. So the first thing I want you to notice in the Champernowne Constant, we're going to call all these numbers here terms. So if it's a counting number and it's in the Champernowne Constant, we're going to call it a term. So 10's a term, 100's a term, 2, 3, 4, they're all terms, all right? Now the first thing we want to do is pay attention to how many of each of these terms there are. So from 1 to 9, there's 9 of these terms. From 10 to 99, there's 90 of them. From 100 to 999, there's 900 of them. We're going to go ahead and rewrite that differently. I've gone ahead and done that beforehand, but we're going to write this as 9 times 10 to the 0. It's come to be important later. Then we have 9 times 10 to the first, and then we have 9 times 10 squared. Now we have right below that here is finding the number of digits in those, all right? So what I've done here for this first one, we've multiplied by 1. That's just to show the pattern. It doesn't really change it. It's 9 times 1 times 10 to the 0, because 1 is the number of digits in these terms. We've gone ahead and done for this next one, we've done 9 times 2 times 10 to the first, and that's given us the number of digits here. And then 9 times 3 times 10 squared, which is the number of digits here, right? So using this fact that we have here, we can rewrite all of these as a sum to figure out the total number of digits up to a certain point. So right now, what we have, we can find the number of digits by adding these all together up to 999, right? So what we're going to go ahead and do, we're going to make a table over here. My bad, sorry. We're going to make a table over here. And this is going to have our, in a second, we're going to write 10 to the m up here, and I'll show you the sum here in a second. We can go ahead and write the table. We're going to have our range of numbers. And then we're going to have our number of digits. Now, how we're going to go ahead and calculate those? We're going to calculate ones up to 10 to the 0, up to 10 to the first, up to 10 squared, up to 10 cubed, and so on. Right? So how we're going to, and we know this is, the range of this is 0. This one is 1 to 9. This one here is 1 to 99. And this one here is 1 to 999. All right, now we just need to calculate the digits. And since these all follow a very similar pattern, we can go ahead and write this as a sum in summation form. We're going to go ahead and do that over here. So since all these have a 9 in common, we're going to go ahead and pull the 9 out. And then I'm going to define, we're going to go ahead and write this in a dummy variable of s. So we're going to write s times 10 to the s minus 1 right up there. And our s is going to be a 1. That would be a 0 there. So that gives us the same one up there. And that's going to be from s equals 1 to m, which is going to be our m value that is up here, right? So now we can go ahead and we can plug in each value of m here. So if we plug in a 0, it's going to pop out a 0. And we don't even have to define that because it's being added to the sum. It's only going to be a 0. If we plug in a 1 here, we're going to get 1 times 10 to the 1 minus s, well, 1 minus 1. And we're going to get a 1 out of there, and it just gets multiplied by the 9. So over here we have 0 and we have 9. Then we have, on the inside, we do 1 to 2, right? And that'll give us the number of digits here because it'll be 2 times 10 to the 2 minus 1, which will give us 100, which will give us 20. And then we have the 1 from before, so we get 21. And then we have 21 times 9, which is 189. So the total number of digits up to 99 is 189. With a similar process by plugging in 10 to the third, or not 10 to the third, plugging in a 3 for m, we're going to go ahead and get 2,889. In this process, you can carry on, and we're not going to go any farther because we're only trying to solve for the 1,000th term of this. But what we're going to do next is we're going to actually be able to go ahead and solve for the 1,000th term. Because now we have sort of an index of where it would lie, and we're looking for the 1,000th digit, and we know it lies between 189 and 2889, right? So the first thing we're going to do to find the 1,000th term, we're going to save that sum here. We're going to go ahead and we're just going to show, we have 1,000 in between here, right? 189 and 2889. Now the first thing we're going to do in order to try and find an index for, sort of how many terms we need, more digits we need to get to it, we're going to go ahead and do 1,000 minus 189, which will spit out 811. That's the number it spits out for us, right? And we're going to go ahead and we're going to solve for it, and then we're going to put this onto a form they use in a formula to try and find this number after we finish solving this. So we have 811 here, right? Now the next thing that we're going to go ahead and do is we're going to divide that number by, we're going to divide that number by 3, right? So we're going to take 811 and divide that by 3. Now the reason why we're doing this is because with N1000, we realize that it lies in between 189 and 289. Well, that lies in between 99 and 999. So it's a 3-digit number that we're going for right here, right? So we know we can divide by 3 here. Our 3 is the value that we need to get the number of terms we need to add to 99, because we're going to add this term we get here at the end to 99 to get where our term is in the position, like what number it is a part of in the Champernowne sequence, right? So we're going to go ahead and do this. This spits out 270. Not exactly. We're going to actually have our remainder here with a remainder of 1. And this will go ahead and give us more of a positions for where we are. So now we have 270. Like I said, we're going to add that to 99. So we're going to have 99 plus 270 equaling 369, right? Ooh, we're almost there. That doesn't really give us our answer, right? So now what we need to go ahead and do is figure out exactly where we are. So remember, this was 811 was the number of digits we need to get to, and 270 was just the number of terms that is. We added those terms there. We still have a remainder of 1, which means we have one more digit to go. So if we write out the part of the series where this is, we have 0.123 ... 368 369 370. Well, we know right here that we're up to this point, right? By adding those 270. Now we have one more position to add. So if we're going from here to there, well, this 3 right here in the 370 spot is our number, right? So I'm going to label this N1000 of C10 is equal to 3, right? But now we're going to go ahead and rewrite this process here so we can solve for any other number. I don't think I have time for this in this video because we're coming up on the 8-minute mark here right now. But I'm going to go ahead and release another video to finish solving this and to also go ahead and show how to do this in any other base, all right? Thank you guys so much for watching. Good luck to everybody else in the contest. See you guys later.